Assalamualaikum warahmatullahi wabarakatuh. So today we are going to continue with our chapter 4.3 and will directly continue to our exercise 6. Okay, so let's read the question here. Here we have methane, CH4, and oxygen react in the presence of a catalyst to form formaldehyde. In a parallel reaction, methane is oxidized to carbon dioxide and water. So we have here two reactions. Suppose 100 mole per second of equimolar amount of methane and oxygen is fed to a continuous reactor. The fractional conversion of methane is 0.9 and the fractional yield of formaldehyde is 0.255. Calculate the molar composition of the reactor output stream and the selectivity of formaldehyde production relative to carbon dioxide production. Okay, take your time, pause the video, and try to extract the information. Okay, I'm assuming that you have extracted the information. So let's reread the question and extract the information at the same time. So here we have two reactants, methane and oxygen react in the presence of a catalyst to form formaldehyde. This statement refers to the top reaction, and this will be our main reaction. In a parallel reaction, methane is oxidized to carbon dioxide and water, and that reflects the second reaction, which is our side reaction. So the first is our main, the second is our side reaction. Suppose 100 mole per second of equimolar amount of methane, CH4, and oxygen is fed to a continuous reactor. Let's directly reflect it to a flow chart. So we have a flow chart here. We have a feed in. And in the feed, we have 100 mole per second of a mixture. What does the mixture contain of? The statement mentioned equimolar amount. So equimolar amount, what does it mean? It means the amount is equal in molarity. So we have here 0.5. If we put in form of composition or fraction, we have 0.5 mole CH4 per mole. We also have 0.5 mole oxygen per mole. Okay. That will be our inlet. And then we will have our outlet. So what will be our outlet? So we need to consider all compounds exist in the two reactions. Because we haven't known whether all reactants will be fully reacted or not. Okay, so we have how many compounds here? We have CH4, oxygen, HCHO, which is formaldehyde, water, additionally we have CO2. So you can write here, and 1, for example, mole of CH4, or you can also put in form of composition, and then oxygen, and so on. It should be 5 in total. Additionally, what else can we write in the flow chart? Instead of writing in form of composition for the feed, we can also translate this into the flow rate of each reactant. So 100 times 0.5 mole per mole, that will be 50 mole per second CH4. Similarly, the rest is 50 mole per second oxygen. Okay, what else? The information given. The fractional conversion. So we have here fractional conversion of methane is 0.9. What does fractional conversion mean? Remember back the formula. We have F representing the fraction. So we have FCH4 is equals to how much CH4 reacted over how much CH4 fed. This is the standard formula. And the answer is 0.9. We have 0.9 here. Then we have calculate. Oh, sorry. And the fractional yield of formaldehyde is 0.855. In the previous lesson, we already learned about yield, where yield, so we have here yield is equals to mole of product form. So yield refer to product, conversion refer to reactant, over theoretical, in theory, how much mole it should produce if there are two conditions. One is complete reaction, or complete conversion of limiting reactant. Second would be if we only consider main reaction. Okay, so this is the formula. Yield usually in the form of percentage of fractional. So if in the form of percentage, we multiply by 100. If by in term of fractional, no need to multiply by 100. So here it mentioned that the answer will be 0.855. Okay. Now the question. The question asks, calculate molar composition of the reactor output stream. So they want what are these? N1 up until N5. And then second question, what is the selectivity of formaldehyde production relative to carbon dioxide production? So selectivity of HCH2 over CO2. That will be mole of HCHO produced over mole of CO2 produced in actual. Okay, so now we have extracted most of the information. So let's go to the next slide. Right. Now I have drawn the flow chart previously, but now to just make so this was the flow chart that we have actually drawn last time. So here we have the feed and also the output. So here we have all the information given like last time. So this feed either you can write as a composition or you can also write as 50 mole CH4. Sorry, 50 mole per second CH4. And 50 mole per second of oxygen. So maybe you can fix with this lah. This is just some information for you to be aware of. Then we have two equations here. These are our outputs. So we have here N1 will represent the molar flow rate for CH4, N2 for formaldehyde, N3 for water, N4 for CO2, and N5 for oxygen. Okay. So okay, so what we do, first we have to try to solve it using mass balance using the extent of reaction. So what are these J1, J2? That represent the number of reaction. And if you remember, we present this J in the equation of extent of reaction. So here we have the two equations. Extent of reaction. Output of is equals plus or minus the summation of negative for reactant, it will be positive for product, and then you have to consider its stoichiometry times the extent of reaction. So here we have two reactions. If the compound are involved in both reaction, then there will be two terms of extent. We have extent 1 and extent 2. But if the compound involved in one reaction, then there will only be one extent of reaction. So what we do, we write the mass balance using extent of reaction for all the 5 compounds that we have in both reactions. Here we have balance. The output is N1. The input is 50. Now we have 0.5, the mole fraction, times 100, which is the inlet, is that will be CH4, inlet lah, input. And then summation of the both extent. So CH4 is actually a reactant for both two reactions. So since it's reactant, we have negative here, negative for the second one. We have stoichiometry is 1, 1. So here we have 1, 1. And then extent 1 and also extent 2. Do the same for formaldehyde. Formaldehyde, we have here N2 as the output of formaldehyde. N2 was not present in the feed, so 0. And then we have N2 as the product, so we have positive. Then here we have 1 only for the stoichiometry, so we have 1's middle here. And then we have extent 1. There will be no extent 2 because formaldehyde is not involved in the second reaction. Go to water, we have water, balance, N3 as the output of water. There is no output, there is no input of water in the feed, so 0. Then water is the product. So we have positive. It's a product for the first reaction and it's 1 here. So here is 1, extent 1. Water is also product for the second reaction. So positive here. And then here we have 2. So 2, then extent 2. Do the same for CO2. So we have here CO2 is N4 as the output. Does not present in the input. So 0. It's a product for the second reaction. So positive. Here is 1, here is 1, and then extent 2. Then we have lastly the oxygen. So oxygen, the output is named as 5. Input is 50 given by the question, where similarly we have 0.5 times 100, we got 50. Oxygen is a reactant for both reactions. So we have negative here as a reactant. Here there is 1, stoichiometry is 1. Extent 1. For reaction 2 also is a reactant, so negative. And then here we have 2, so we have 2, and then extent 2. So we have 5 equation here. Okay. So now, as mentioned in the question, we mentioned that the fractional conversion of CH4 is equals to 0.9. Back to the definition of fractional conversion, fractional conversion is CH4 mole reacted over CH4 mole fed. So how does we come out with this extend 1 plus extend 2? So try to go back to the previous slide. Go back to the general mole plus generation minus equals to how we end up with the steady state accumulation 0. For CH4 is the reactant, so it is not generated, it is consumed. So generation is equal to 0. Lastly, we got this equation where output we move to the other side. We have output is equals to input minus generation. So this minus generation means minus consumption. So minus consumption. Consumption is, it means that how much things react. So that will be minus in bracket extend 1 plus extend 2. How much consumed? How much reacted? That will be whatever in the bracket. Not including the minus, but it will be whatever in the bracket. So that is why we come out with this one on top lah. Have here extend 1 plus extend 2. That means if in case the two reaction involve another stoichiometry. So let's say this is just an example. We have here CH4 plus oxygen to got something. Then the second reaction was 2CH4 plus oxygen to get something else. What will happen? The CH4 mole reacted will be extend 1 plus 2 extend 2. Because there is 2 here. It's 2 here. It's consumed mole of reactant consumed must consider the stoichiometry. It's just that in this case, it's only extend 1 plus extend 2 due to the reaction involved, the chemical equation equal to. And then over CH4 mole fed is equals to 0.9. So how much CH4 was fed? We got from the question it was 0.5 times 100, that would be 50 lah. So here 50, we move to the right hand side. We got extend 1 plus extend 2 is equals to 0.9 times 50, which is equals to 45. So we got one equation. We're gonna do the simultaneous equation lah. This. Okay, and then we have second information where we got formaldehyde yield, which is equals to 0.855. What is the definition of yield? So here is fractional yield, not percentage yield. That's why not multiplied by 100. So yield is equals to how much the product formed. We are talking about how much formaldehyde is formed because that is our main product. Now, it was in the first statement. So how much mole of HCHO formed over how much theoretically it should form if there must be two assumptions. First, the limiting reactant, which is in this case CH4, reacts completely. And second, only main reaction is considered. Okay, so in the starting of solving this exercise, we did not mention which one is limiting reactant and which one is the excess reactant. So you can go back, confirm back, is it true that CH4 is actually our limiting reactant? Okay, so, and then the answer is 0.855. So I'm going to skip that one. Okay, so how much is HCHO formed? So we can go back to the same equation. In the value So we have here, this is the input, this is the generation, back to the generation. So here we have extend 1 as generation. Have That's why here we have only extend 1. So how much moles of HCHO form if limiting reactant CH4 reacts completely? That's 1. And second, only main reaction involved. How do you know? You go back to the equation, the chemical equation. That will be the main chemical equation, which is CH4 react with oxygen to get HCHO plus H2O. Was in the question just now. So we have here one CH4 should produce one HCHO. Currently we have 50 CH4. So suppose 50 HCHO should be produced. So that's why we have 50 here. That will be equal to 0.85. Hence, we can solve what is extend 1. So here we have extend 1 is equals to 42.75. Then you can put the information in the previous equation here. Then you can solve what is extend 2. Then we got extend 2 is equals to 2.25 mole. Okay, that's how we solve the extend. Why are we actually solving this extend? This is because we come back to the question where we actually were asked on the molar composition of the product. We are interested in N1 up until N5. So we go back to the balance for all CH4, HCHO, H2O, CO2, and oxygen. We put the value of extend 1 and extend 2 into the equation. Then we are able to solve our N1, N2, N3, N4, and 5. So here we have 5 mole per second methane, 42.75 mole per second formaldehyde, 47.25 mole per second water, 2.25 mole per second carbon dioxide, and lastly 2.75 mole per second oxygen. So we got this value after we put the value of extend 1 and extend 2 in the mass balance written using the extent of reaction. So we add up all, we got total molar flow rate, which is equals to 100 mole per second. Interestingly, our feed is also 100 mole per second. So why is it the same? In a reactive system, is it supposed to be the same? Does input equals to output? Think and tell me the answer in the next class. Okay, now we already have the total molar flow rate of the output. We have the molar flow rate of each component of the output. What we are going to do then, now we have to find the composition. How do we find the composition? So Y, which is the composition, is equals to Ni over N total. That will mean the mole of the individual compound that we are interested in. So that this will be Yi lah, over the total mole. So total mole is 100 mole per second. How much is YCH4? That will be 5 over 100. That will be 0.05 lah. Now we can do the same to all to get the molar composition for all. So here we got Y1, which is referring to CH4, is 0.05 mole per second, CH4 per mole, Y2 for formaldehyde, Y3 for water, Y4 for carbon dioxide, and Y5 for oxygen. So we answered the first question. The second question is they're asking for selectivity of formaldehyde production over CO2 production. So what is this selectivity of formaldehyde over CO2? So that would be mole of formaldehyde over mole of CO2. So in the previous slide, we have mole of formaldehyde will be 42.75 mole per second. This was in previous slide. Or simply Y multiplied by 100, which is the N total lah, over CO2 is 2.25 mole per second. So with that, we got it is equals to 19. So here, selectivity is mole HCHO over 19 mole HCSO, the formaldehyde, over mole of CO2. So now we have answered the second question. Okay, that's all for today's lesson. We're going to continue with chapter 4.4 in the next lesson. So thank you everyone for listening to this class.